Right guys, I want to talk a bit about SWR dips and resonance and why the two are not necessarily the same. And I think this perhaps catches out some newer hams and perhaps some of us that have been licensed for a little while. You know, I can put my hand up that this is something that caught me out when I was a new ham, and this is why I want to actually talk about it. So yesterday I set up an antenna out in my garden which was for 40 meters. So I'm building an antenna system called a phased vertical array, this is two identical 40 meter ground mounted verticals. Okay, now that's not really important just now, but what I'm going to talk about is important if I wanted to do that. Now, when we see a nice SWR dip on that SWR meter or analyzer, whatever, that doesn't necessarily mean that you are at the point of resonance. So the definition of resonance, well, if we talk about SWR, okay, so SWR is made up of two components. We've got a resistive part, which is R, and then we have a reactive part, and that could be shown as J, but on antenna analyzers, it's usually shown as X. Now, if we are bang on resonance, the X will equal 0. So if it's X, if it happens to be X minus, then that means that the reactance is capacitive. And if it is a positive figure, then that means that the antenna is inductive. I have to try and remember to get that the right way about. So if it's capacitive, then the antenna is short. And if it's inductive, then the antenna is long. Now the SWR calculation, SWR impedance calculation is a mix of those two figures. So where you have your low SWR or your SWR dip, that's not necessarily where resonance actually is. Now my rig expert AA55 zoom actually shows you where the resonance point is, and it shows you where the reactance goes through 0. Shows you on a nice graph. Now, some of you will rightly say, well, what does it really matter on a quarter wave vertical in practical use? And that's true. It probably doesn't make any difference in practical day-to-day use. But if you want to understand antennas and you want to do a bit more experimentation, then this is something that you really need to know. Now, when I was setting up this antenna yesterday, now the antenna happened to be a bit short. That's why we see a resonance of 7424, so it should be down at 7.1 megahertz. But that's where the resonance is, so there's no reactance at that point. But if we look where the SWR is, slightly higher, 7445. So it's about 20 kilohertz of a difference between where the resonant point is and where the lowest SWR is. Now, our 40 meter band in the UK or in Europe, what's this region, 2, 3? We have got a band allocation of 200 kilohertz. Now, that 20 kilohertz is really quite insignificant. You can put your low SWR right in the middle of the band, and it's not gonna make any difference whether you make, if you go by the resonance or whether you go by the low SWR, okay? It won't make any difference on a ground mounted vertical. But in my application, where I'm looking at phased verticals, and both antennas need to be identically electrically the same, they need to be within a few kilohertz of a resonance, so X equals 0, and I can't stress that enough. So that's really important that, it's just something to think about, guys. Now I did fix this problem with these antennas, but that's really as a subject for another video. But if we think about a ground mounted vertical, nominally the impedance should be X0 and the R 36 to 37 ohms. Now typically we don't see that. Typically we see, well, in this example here, I'm showing here is about 44.7 ohms. So that could be for a number of reasons. It could be for things acting or reacting to the antenna, but a lot of it's probably to do with the ground and the ground conditions, and a lot of that slightly raised impedance is ground losses. So if you have a ground mounted vertical and you see X equals 0 and R equals 50, that's great. It matches great to your 50 ohm coax, but I would say you have excess losses in your system, and you need to make your ground a bit better. Either raise the feed point up, use elevated radials which are tuned, so i.e. the same length as the vertical element, or get more radials on the ground. That's something that you can do. But I think this is just quite a quite an important lesson that I think we all should know. And I think, as I say, I think perhaps some of the newer hams out there perhaps just don't realise this, that the two are not the same. Now, another example we could talk about is a Yagi antenna. So a dipole nominally has an impedance, I think about 72 ohms. Now, when you convert that to a Yagi, so you put an element either side of that driven element, a reflector, a director, you create something called mutual coupling, and that causes the impedance to get lower. So in most Yagis, you'll see a method of actually matching on it. Typically, you might see something called a gamma match. So you wouldn't shorten the elements, you use this gamma match to then bring it into an acceptable SWR. So it's applicable on all antennas. So I think we've just got to be careful what we actually say, guys. And when we're actually talking about, again, talking about low SWR and resonance, because the two are not the same. Right, guys, just a quick one from me. We'll catch you in the next one. Bye for now.